All right, hello everyone. I'm Sam Rowe and I work at Red Badger. Today we're going to be talking about what ReasonML is and why might it be interesting for a React developer. So ReasonML is a new language with really good React integration. It's developed by Facebook and was actually created by Jordan Walk, the same guy who created React originally. So Reason promises to give a much nicer and simpler development experience than JavaScript or TypeScript. So now Reason is actually a new syntax for a language that already exists called OCaml. And OCaml is a functional programming language that's been around since the 90s, and it compiles down to really fast native code. Now you might be thinking OCaml sounds like an odd choice for writing React apps, but there's actually a tool made by Bloomberg called Bucklescript that compiles OCaml down to lightweight JavaScript. So odds are though you've probably never heard of Bucklescript, even if you haven't encountered Reason already, as it hasn't seen that much adoption on its own. And the reason for this is most likely that OCaml has a very alien syntax compared to what most JavaScript developers are used to. And this is where Reason fits in. So Reason tries to smooth over the syntax and tooling to make OCaml and Bucklescript ecosystem a lot more accessible to JavaScript developers. So all of this sounds like a lot of faff. Why would we bother? What is there to like about ReasonML? Well, first of all, it can actually get you a much simpler development experience, much simpler tooling setup. At the moment, you probably have to work with a load of different tools like Babel, Flow, Prettier, TypeScript, ESLint. With ReasonML, these are all consolidated into one tool chain that does all of these tasks better than the individual JavaScript tools can on their own, because they're all integrated into the language. So let's run through these and see what the benefits are we get. So Flow and TypeScript both layer types on top of JavaScript. I'm sure we've all had plenty of errors like undefined is not a function, cannot read property X of undefined. And in a dynamic language like JavaScript, these kind of errors are very hard to avoid in a large code base. Now obviously not only is this bad for users who have to suffer buggy apps, but it also sucks for developers. If every time you make a mistake you get an error in a far off part of your app, that you then have to work backwards from in order to find out where you actually went wrong, that's going to slow down your development experience quite a bit. So not to mention the time wasted debugging error reports that are like, oh, I pressed this button in the app and then it crashed. And all of this slows down our developer feedback loop and velocity. So having a lot of unit and integration tests can help. But again, you have to take time to write all these tests, and they tend to be quite brittle. So often you have to spend time updating them when you change the functionality of your app. So now a good type system can help a lot. For a small amount of effort, adding type annotations to your code base can catch a large number of these errors at the source as you're coding, without you having to wait for your code to run or your test suite to run to catch the bugs. Now both Flow and TypeScript help you out here by letting you add types to good old JavaScript. However, JavaScript is a dynamic language, and all of its APIs and idioms play to the strength of a dynamic language, not a statically typed one. So while they make it possible to achieve a lot of type safety, that doesn't mean they make it easy. The type system tends to be only as strong as you make it, so you either end up with a lot of verbose annotations or a lot of variables that are implicitly typed as any, which partially defeats the point of having a type system in the first place. So because it's a language designed for the ground up to support static types and exploit the benefits of them, Reason gives you a much more solid type system for a lot less typing. Being able to get instant feedback when you've made a mistake or forgotten something without having to switch out of your code editor can be a big productivity boost. So another tool you've probably spent too much time configuring and setting up is Babel. So ReasonML is a compiled language that outputs JavaScript. JSX is built into the language. There's no syntax plugins or browser support lists to set up. There's just one tool that type checks your code and then compiles it to some JavaScript that's widely supported. So we can ditch Babel. Prettier is another great tool that you should all use if you don't already. If you're not familiar, it automatically formats your code, so it saves you a bunch of typing and pointless arguments with your colleagues about formatting. But again, this is another tool you have to install, configure, set up an editor plugin for. The Reason toolchain has a tool for this called Reformat, built in that also formats your code. But it's included in the Reason Language Server plugin for your code editor. So if you're using the Reason VS Code plugin, for example, that single plugin will handle syntax highlighting, type checking, compiling your code, formatting your code, all in one place, rather than like you and everyone on your team having to install like 8 different plugins to achieve the same thing. And now when you have solid type checking, automatic code formatting, you don't really need a tool like ESLint. Checks for uninitialized variables and bad formatting are already handled by everything else. So that's another config file and editor plugin we can get rid of. So now we have all these tools that are required for modern JavaScript development provided in one cohesive bundle. Now another benefit of ReasonML is that it's a functional language by default. So almost all of the types and data structures in Reason are immutable by default, and this plays really nicely with React, where generally we only want to use immutable data. But if you do find yourself in a situation where you need to use a little bit of mutation, you can explicitly mark variables or fields in an object as being mutable. Or you can use a for loop if you want to avoid writing some crazy reduce function. So all of this is a very pragmatic approach, especially for beginners to functional programming. So having all our variables and data immutable by default prevents a lot of accidental errors, but we can still use mutations if we have to, and it's explicitly signposted in our code when we do. So another really cool feature of ReasonML is variants. The Reason docs describe them best. So most data structures in most languages are about having this and that, whereas a variant allows us to express this or that. So here's an example of what a variant looks like at the top. And that says that any variable which has the type myResponse variant is either going to be a yes, a no, or pretty much. Now, to do something useful with a variant, we use probably the best feature of ReasonML, which simply doesn't exist in JavaScript, TypeScript, or Flow, which is pattern matching. It looks similar to a switch statement in JavaScript, but it's much more concise. So we just list out all the constructors in our variant, and then we can specify what we want to do with in each case. If we forget to handle one of the options, then the compiler will automatically catch the mistake and give us an error telling us to add the missing constructors. Also, each constructor in our variants can hold extra data that we can then extract and use when pattern matching. So here, Instagram holds a string, Facebook holds a string and an integer. So let's see a real-world example of a very commonly used variant called option. So this is used to model nullable types, where in JavaScript you might use null or undefined, for example. So if we do have a value, then we store it as a sum. If we don't have a value, we store it as a none. As Reason forces you to handle both of these cases, we can never get a null error. This is how Reason could save you from a lot of cannot read property X of undefined errors. Now, variants are a really great tool for modeling state. Often different fields in your state are only meaningful when your app is in a particular state. So variants let you only keep the fields that are actually meaningful when your app is in a particular state. And the compiler's type checking will always make sure you handle every possible state your app is in. And bad state is a huge source of bugs, which can be mostly eliminated using variants. And it's also a much nicer way to model your state. So that's a high-level overview of the main benefits of ReasonML. Hopefully that's piqued your interest. Hopefully you might see if it's a good fit for your team. So thanks. Any questions?
Yeah, I was just wondering, how easy is it to convert an existing code base to ReasonML?
Yeah, it's really straightforward. So the Reason compiler will convert each Reason file into one corresponding JavaScript file, so there's a one-to-one mapping, in line with where your Reason files are kept. So if you have like module.reason, that will then become module.javascript. And then you can just, in your JavaScript code, import module.javascript as you would usually.
Do you use it for your day job? What do you do with it?
No, just played around with it whilst on the bench, but to see if it would be a good fit for a project. So, unfortunately not.
The question is like, where is Reason? Like, unfortunately, I don't see many people using it. I don't see many communities that are active in promoting it. And yours is like the first talk that I've actually seen in London.
Fair enough. I mean, it's a quite new language. I think it's only like 3-4 years old, perhaps. I mean, I can't really say for sure why it's not more widely used. I think perhaps because it's still in early development, there's still rough edges. I did find it overall pretty good to use when I tried it out, but there definitely are some rough edges, like certain tools like Webpack. You still have to use Webpack, set that up to compile your Reason, so it's not quite fully there. When there's like I think an all-in-one tool that compiles your Reason and Reason code and bundles it and does the full like producing a bundle for production, I think that's when it would probably become a lot more popular, but we'll see.
Have you tried using it with third-party libraries, and what's the support? And if it's not supported by some third-party libraries, how easy it is to provide your own typings, like with TypeScript is very straightforward?
Yeah, I found it fairly straightforward to create my own typings for IndexedDB. There's like community packages out there for like, so there's like Reason React Native, which provides like types for a lot of the built-in React Native code, I guess. But yeah, so generally, usually there'll be for big projects, there'll usually be something like called like BS, whatever the name of the package is, which is the BuckleScript types for that package. Similar to how you have like definitely types for TypeScript. It's a similar sort of thing there. It's not too hard to write your own, I would say. But yeah. Also, you can just use JavaScript untyped if you want to. But obviously, there you're giving up type safety.
Cool. Okay. Thanks very much, Sam.
Cool. Cheers.